Another cell technology. Huasun is dedicated to heterojunction cell technology, and Chris will talk about cells and modules for utility scale PV parks and the CI segment. Chris, the floor is yours. You have to unmute yourself.
Yeah. Can you hear me now?
Wonderful.
Okay. Hello, Michael and team of TaiyangNews. I'm glad to be here to make the presentation. So I shall share my screen right now. Can you hear? Can you see my screen?
Perfect.
Okay. So thanks, and I'm going to talk about our heterojunction technology and also our products in this like 15 minutes. And okay, let's get started. So first, as Huasun is quite like new players in the PV industry, so I would like to make a little bit of the background about the company and the capacity that we have up to 2020 Q2. Now, the Huasun company was established in July 2020, and our company is focusing on heterojunction and N-type heterojunction technology only and also in cell manufacturing and also in module manufacturing. Up to now, we have two phases of our capacity with the 2.7 gigawatt of the heterojunction capacity both in cell and module. 2 gigawatt was a G12. That's what I'm going to talk mainly of this presentation, and we have the first phase of 700 megawatt of the M6, which we have been delivered since mid of the 2021. So a little bit of the background of the heterojunction technology. It's a combination of crystalline silicon and the thin film technology with excellent light absorption and polarization effects. So with compare with the mine steam technology perk, we have the advantage of the higher efficiency and also better performance. And in other hands, the heterojunction cell also have industry highest bioefficiency. It's up to 95%, 93 to 95% up to on the cell level, and over 90% on the module level if we are using the transparent back glass. And also heterojunction has the best, let's say, low temperature coefficient based on the N-type wafer, and also the excellent low light performance. Meanwhile, heterojunction is also a technology which we call a platform technology that we are able to bring other cell technology with heterojunction to make a combination. For example, IBC and heterojunction can be HBC, and also the promising future technology perovskite with heterojunction to be the tandem cell. So that's why we call it a platform cell technology. So here's something about the what happened in the past like 10 years in different kind of development First, it's about the wafer size and the cell size and also the cell technology from mono, poly, G1, and to N-type heterojunction, and also TOPCon into M6. And we are also now we have now in G12. So the cell size is increasing, and also the technology is improving with about 30% in the cell efficiency increase in the last 10 years, and which is another significantly change in cost reduction for the LCOE. Here is our kind of roadmap for our cell and module development. Last year, we started with M6 heterojunction, and we achieved average massive production, average efficiency to 24.5%. And with M6 module, 144 cell up to 475 watts. And this year we started with the G12 cell and the module manufacturing. So we are going to making the cell efficiency increase, and also with the module output increase for the next 5 years. And in 2025, we will start the Titan cell pilot line. Hopefully that our cell efficiency on the highest part will reach over 28%, and the modules can be 800 watt modules. So on the cell level, we have a lot to improve. That's why we said that heterojunction have a lot of the potential still here to increase the efficiency in next few years. And this year in our G12 cell manufacturing, we have already applied the microcrystalline technology on the front side. And in our next phase capacity expansion, we will introduce microcrystalline in both sides of the cell to increase the efficiency, and also with other cell efficiency increase methods. And we also apply the SMBB for our module manufacturing with our equipment manufacturer to adopt 15 bus bar for our G12 heterojunction module. So next is about the information of our heterojunction HJT Himalaya G12 series product. So our topic is about for the utility products. So the major product will be our G12 132 cell half cell module, which power will up to 700 watt with the efficiency up to 22.5, and with the leading lowest temperature coefficient up to minus 0.26% per Celsius degrees. So this module is manufactured by our SMBB technology with 15 bus bar design, and this is one of our research direction that we will also trying to increase our bus bar maybe to 18 or even more. And this G12 heterojunction module already using the zero cutting loss, because we are processing with the cell with a half cut wafer. So there will be no cutting loss for the module manufacturing. And with the white mesh back glass, the bioefficiency will go up to higher than 85%. And with the 15 years of workmanship and 30 years of performance warranty, it's the perfect for utility projects. And we have the size and the weight of the module here as well. And this one is this slide is about the whole series of the 3 type of the module with 132 cell and 120 and 110. So by heterojunction, we are empowering the world by heterojunction technology, because this one 700 watt solar module is best for the super large cycle ground power plants, and with lower BOS costs and better LCOE and more lifetime power generation, and of course with higher return on the investment. So we have made some LCOE scenario about our G12 module with a scenario of the installation in Hainan province in China with grassroots, 100 megawatt install capacity with a fixed mounting structure with 15 degrees of the installation and 1 meter distance to ground from the low site. So we have compared with our current, let's say, major technology with PERC bifacial M10, Topcon bifacial M10, and PERC bifacial G12. So about the compare with the baseline of PERC bifacial M10. And the conclusion is that on the LCOE cost that we are on this kind of installation scenario, that the 6.6% of the LCOE cost can be improved. But every installation should be, let's say, calculated case by case. And for heterojunction, we are thinking we think that it is for the new PV era that we have a great advantage in efficiency, performance, and also in lower carbon footprint, because we have the heterojunction is a kind of a technology with a lower temperature processing. The whole processing temperature is lower than 250 degrees, which means less energy consumption, and the processing is simple with 4 steps. And yeah, for more information about the lower carbon footprint, we can discuss later if you would like to hear more. And yeah, Huasun believes that the heterojunction will become the next mainstream technology in the new PV era, which is, I think, is the N-type era. We're also leading the development of direction of the PV industry. So here's some next few slides about the advantage that we conclude for heterojunction technology compared with the mainstream PERC. First, one of the most important advantage is the industry-leading lower temperature coefficient. We make such kind of a scenario about comparing heterojunction, mono PERC, and also there's mono, and in 500 watt modules in 65 Celsius degrees of the temperature, that in the loss in from heterojunction is less, and which means the any power generation will be around 4% compared with PERC in such kind of climate. And also the bioefficiency benefits can help to gain about 3 to 6% depend on different installation conditions because of the biofacility, higher biofacility of the heterojunction cell. So after the assembled into module, because of the white mesh that will cover part of the backside of the cell, the biofacility which I mentioned is 85%. But if we're using transparent back glass, that the biofacility will go up to over 90%. So with different kind of ground, that the biofacility power generation gain from heterojunction module compared with other bifacial modules. We have such kind of chart explaining the power generation difference. And last is also about the weak light performance, because the heterojunction is a combination of crystalline silicon and also the thin film technology. So that one of the advantages of the thin film is about the weak light, we call the low radiation power generation ability. That will also brings like 0.5 to 1% for the heterojunction modules in power generation. Last is about the advantages about the lower attenuation, because of the first year 1% and average annual linear attenuation is less than 4%, 0.4%, and which this is also comes from the benefits of the N-type wafer, as there's no bio effect and to active LID, and also the special film, TCO film for heterojunction is excellent in NTPID. So that we are getting again around 1.9 to 2.9% more of the power generation according to the lower attenuation. So together from the two different directions of to make the product heterojunction technology better, we have discussed already about the high power generation ability, and also we are using the some of our specialized technology for improving the high reliability of the modules. For example, we using encapsulate with the EPE, and we are also introducing a specialized sealing technology we call the PIB sealant, that is especially designed for heterojunction technology because of the much better humidity resistant. So we about the applications, because our company is quite new. We just started our manufacturing since last year. We and we just started our G12 cell and module manufacturing. So we are now we have one of the biggest project for heterojunction and tracking system in Bulgaria. With the total project, it goes up to 350 megawatt, and we are starting supplying the project since last year, and the project still working on. We are continuously supplying the modules. And last is about like to build a zero carbon world. We are looking for, as a new players specialized in heterojunction, we are looking for partners interested in heterojunction technology all over the world, and to work together to bring more, let's say, power plants with our technology, and with the ability to generate more, let's say, power generation with our technology. And again, here's the contact. So if you have any questions, we can communicate in the chat room and also exchange by emails. So Michael, I'm finished.
Wonderful, Chris. Also very impressive. Maybe just two questions from my side. Anyone else, please, in the chat. So when you talk about high efficiency modules, you obviously usually think about rooftop applications. How important is this strategy-wise, the utility scale segment for you when you've designed your products? It's impressive to see this 700 watt module, the efficiency, performance, LCOE. Obviously, capex wise, I think the price is somewhat higher than for a traditional PERC module. So first of all, what's your strategy with the utility scale, and what's your feedback from customers when you approach them with a somewhat higher price than a competitive PERC product?
Yeah, basically we choose. Actually, we are not choosing the size of the let's say wafer, because we will expand our capacity in next phase with both maybe a G12 and M10. So this is not our concern for the cell size and wafer size. We mostly care about how we can improve the efficiency and also cost reduction. That's our major work, to bring heterojunction to like all of the applications. So we use G12 because first, because we, to develop a new technology, we needed to expand the capacity in order to with the cycle of the production to reduce the potential cost. So the utility is one of the best choice to start with. So that's why we started with the G12 first for the utility. And yeah, for the residential and the C&I, that's we will also looking into by first by our M6 currently we have, and we are delivering also a lot with M6 now, and we will also expand to M10.
Mm-hmm. And how is the reaction of the market again as to your utility scale product? Because I think this Bulgarian product is probably one of the largest in Europe once it's done.
Currently, yeah, I'm in Bulgaria now, so I'm going to visit the sites just a few days later. So according to our customer, that the performance, especially worked with the tracking system, is showing the benefits against the original like PERC technology with the P-type technology. And we also have the feedbacks from our customer in Southeast Asia that by using the heterojunction HJT technology with a special like hot climate, the power energy yield is quite let's say interesting, that most of our customer, they are waiting for we are going to have a like big size wafer with big size cell to make the module, because it will help to in the BOS cost to the same level, and it's around, let's say, 8 to 10% more of the energy yield also in Southeast Asia.
When will this big project be finished? Because it's being built.
The first phase will be finished in, I think, very soon, and we are already starting in discussion in the second phase.
So that means all the 360 megawatt will be heterojunction from you, or?
Yeah. Currently, yes. We already signed the contract.
Okay, super.
For supply, yeah.
Okay, thanks. So if anyone has questions to Chris, I already see some. Please write it in the chat, and Chris is happy to answer. Thanks a lot. Very interesting. Okay, we're coming to our final presentation.